Methali Barapatre. Today I am going to show you what I have learned during my 1 month of IoT internship by Emertxe. So let's start. First we start from what is IoT. That's that's Internet of Things. IoT is a technology in which physical devices are connected to internet to collect and exchange data. It refers to network of physical objects, things embedded with sensors, software and that enables them to collect and exchange data over internet without human to human or human to computer interaction. In simple words, IoT connects non-living thing with the living thing to easy our day-to-day life. So here I have four boxes in which I write things, connect, collect, and act. So basically things things we use for con- things these are a physical devices. Things are physical devices with sensors or actuators. Examples like temperature sensor, smart bulb, Ardiuno, etc. Second is connect. This means connecting device to the internet or network using Wi-Fi, Bluetooth or internet. Third one is collect. Collect is in this the devices collect data from sensors. For example, motion, light intensity. This data can be stored in cloud or platforms. And last one, which is act. It based on collected data. The system takes action. For example, turn on fan if temperature is high. Next, IoT applications. IoT have several applications such as smart manufacturing, smart homes, healthcare, smart cities, agriculture, smart transports. All the things are used or all the things are IoT is applicable for all these things. Let's take an example of healthcare. So, in healthcare, applications can be remote patient monitoring, smart wearables, and how it will work that device measures heart rate or BP. Uh, this sends data to cloud. Cloud um, doctors monitor by their dashboard and alert sends in emergency. If there is any alert, that then it will be sent to notify the doctor or the patient. Next is our layers. IoT architecture have four different layers. First one is physical object. Second layer is transport. Third is intelligence or cloud. And fourth is user interface. So basically, in first layer, which is a physical layer, it includes sensors and actuators, and its function is to collect data from environment. Second one is transport layer. It is used for transporting the data to the cloud. Third one is the cloud, which updates the data. And fourth is user interface. So, user can check the data or change it if if it want to change. Next, so the our topic of uh, our project topic is smart factory monitoring system, in which we have some general use cases. Those are Environmental monitoring. By using this smart factory system, we can monitor environment, safety, and emergency response. So, it belongs to if we have any kind of emergency, then it will notify us. So, like an alarm. And third one is remote control, so that we can control it remotely. Fourth is predictive maintenance. Fifth one is production visibility. And sixth one is trend analysis. These are the general uses. And next, let we move towards next challenge, which is problem statement challenge. So we have four types of problems in this. First one is no real time visibility, delay incident response, no remote equipment, and fourth is the reactive maintenance. So for tackling these problems, we have one solution. So let's move for our solution. So our solution is a distributed multi-node IoT system using Arduino Uno. So in our project, we have made two nodes. Node 1 is production line and node 2 is warehouse. So basically we have make a code which is exported by Arduino IDL and um, into the Thingsboard cloud. So let's start how we have done this process. Firstly, we done code using Arduino IDE. So in Arduino IDE, you can see that this is a void setup. So in this, we write our one-time declaration, and in void loop, we write our logic, that what we have to done, or for how much time we have to on the LED of the after how much time we off the LED, etc., etc. Uh, let's move ahead. So we have done our both codes, such as Node 1 code for production line and where Node 2 code for warehouse. We have done it from Arduino IDE. Next, Picsim Lab. It is a software tool used to um, connect, used to connect and show devices. It is a software tool, as I don't have any hardware tool, but using this, I don't have any hardware kits or devices, but using this tool, I can connect it. So in this Pixim lab, here is a file where we get sub codes, um, in which where we get many options, and one option is for load hex file. So from Arduino, by in Sketch there is export binary. So we done it, and after doing this in Pixim Lab, we open the file where we can load our hex file. Here we also have modules where it has two options, oscillation, and second one is spare parts. By using those spare parts, we can show our sensors, actuators, and other things. Next one is our Thingsboard. It is a platform where we connect, it is a server where we connect network, our Pixim lab to the network, internet. So in this Thingsboard, which it is a open source platform where you have to log in one time and you can use it. Here you can see in home there is a lot of options such as alarms, dashboard, reporting, AI solution creator, solutions, template, entity, devices, assets, entity views, gateway, profiles, customers, users, and so many things. So using this you can develop your dashboard. So I have put one more image for more detailing or exploring. Here you can see that I have done a smart factory project where there is some production line. I have downloaded some charts. So, I just want to show you that you can the add some charts and whatever you want from here by selecting widget bundles. You have many options and you can create your dashboard using these options. Next, this is an example of data telemetry. We have done a code on Ardiuno IDL firstly. Then we load it into Picsim Lab, and after that we connect it to the Thingsboard. Now the question is how we connect it to the Thingsboard. We there is an there is a access token which we have to copy from here and paste it to our original Arduino code. So it will connect the things code and our load file. Next one is so let's see what what kind of sensors we have, what kind of sensors we have used in our node 1 and node 2. So let's start. Firstly, DST22. This is a sensor. We this sensor we use it in both our node 1 for production and node 2 for warehouse. We have used for both. Mm, DST22 is a digital sensor that provides temperature reading and humidity reading. It gives more accurate result compared to DST11. DST11 is an old version and DST22 is a new version. So basically, DST22 gives temperature and humidity readings. That's why we use it in our Node 1 and Node 2 program. Next is relay. Relay is an electrically operated switch. It allows microcontroller to turn on and off devices like bulb, fan, application. In our smart factory monitoring project, we use relay to indicating or on and off, or to turn on and off the switch on from the dashboard. So we have used relay in our both the node 1 and node 2 program and both use it in Pixim lab also. We use LEDs to in here for relay we use LEDs and connect it to pin number 3 for indicating the status if of the dashboard. Next is LM35. It is a precision temperature sensor IC that gives output in analog voltage directly proportional to the temperature. We use LM35 in our Node 1 program, and we have connected it to A0. Next is our Ethernet in Ardiuno. We have used Ethernet shield for our both the program to connect it with internet. So using Ethernet, Arduino can send sensors data to internet, connect to sensor servers such as like we have used Thingsboard, control devices remotely, and required and it requires Ethernet shield. As per I told, in our both the Node 1 and Node 2, we used Ethernet shield. Next is our LED. So LED, we have used LED for indicating status. Such as we use three LEDs. We use red LED for off status, off state. We use green LED for on state and yellow LED for error condition. We have connected red LED. We have connected green LED to pin number 5, connected yellow LED to pin number 6, and red LED. In node 1, we have connected to pin number 7, and in node 2, we have connected it to pin number 8. Next, LDR. LDR is a sensor that changes its resistance based on light intensity. More light, low resistance, less light, high resistance. S- uh, we have used LDR in our node 2 program and connect it to A1, pin number A1. Next is our door sensor using switch. We have used some uh, switches and give it name as door sensor. Switch is used to detect door open or close. Door close, switch on. Door open, switch off. Used in security and automation system. Here we use switch as door sensor to see our door is on or off by indicating a switch. It is also used in motion sensing, and we use switches also. We have used different we have used switches in different conditions also. We also use it as motion sensor. So next is our push button for motion sensor. Sorry, I am get mistake. One mistake here. A push button switch can be used to simulate motion detection in place of a sensor. When press, act like motion detect. When release, no motion. So we have also used push button for motion sensor. We connect motion sensor to pin number 4 or pin number 4. Thought so. Sorry. Pin number 5. Next. Let's let me show you what I have done in my smart factory monitoring project. First, I want to show you my code. This is my code for node 1, in which we have include sensor manager.cpp.h, actuator.cpp.h, config.cpp.h, network.cpp.h, network.h, telemetry.h, rcp.h. So Here we have included several libraries also, and my code is done here. So I will show you what I have done in Pixim Lab. This is my Pixim Lab for Node 1, where you can see I will connect my Thingsboard also. This is my Thingsboard in my production line monitoring. You can see that when I temperature, increase or decrease temperature, this temperature also increases or decreases. See, decreases. As I increase it, increases. One more thing, we have added humidity also, time series chart where we have shown temperature and vibration, some machine status that will show our machine status, that if it is on or off. This is a time series table which shows data for every 30 minutes. It's showing data for temperature, humidity, LM35, machine status, relay status, sensor error, and vibration. One next thing is when we switch on the dashboard switch control, relay status will on. When we off it, it becomes off. Our next is our node 2, which is warehouse. So let's start with node 2. This is our node 2, which is warehouse, and my Thingsboard program for it is you can see we have added temperature, humidity, LDR value. As we change LDR value, this value will also change. See, next is our when we on the switch, our relay is also on, relay status on. Next, I want to show you my smart factory. In this, we have shown our both Node 1 and Node 2 programs where we see the readings of temperature, humidity, and so many sensors which we have used in our Pixim for production and warehouse. And this is the time series chart for temperature and LM35 temperature. So thank you. This is our smart factory monitoring project and the things what we have done in our smart factory monitoring project. Thank you.